So here's that brain stem. So here's the whole brain stem, and we see a little bit of spine. I know that's not on the list, but there's the spine, medulla, and the pons, and then the midbrain. Midbrain's not on the list yet. It is later, but why we're here, since we're talking about brain stem, here's the midbrain, right on the top. So medulla, pons, midbrain. Medulla, pons, midbrain. Okay. The cerebellum is back here. This walnut-looking structure. There's the whole cerebellum. Vermis, by the way. Cerebellum there. Cerebellum here. Cerebrum is the big wrinkly part. As we know, it's kind of an easy one. So the cerebrum is this big outer wrinkly part of the brain. Okay, then the next row is the lobes of the cerebrum. They're not super well defined, but frontal lobe here. This is the front of it. The forehead would be here. Frontal lobe. This is the central sulcus, and I know you don't have to know it, but it does separate the frontal lobe from the parietal lobe. So frontal lobe here, parietal lobe here. And then as we get down to the bottom here, occipital lobe. Occipital lobe in the back. Temporal lobe by the ear. We got a little bit of connective tissue and blood vessels. Alrighty, so this is temporal lobe. Frontal, parietal, occipital, temporal lobe. Same. Corpus callosum, fornix, olfactory bulb, and tract. Here's the corpus callosum. This is actually white matter, but it's this strip, kind of arching strip, is the corpus callosum. It's really quite easy to see. To me, a surprising number of students get it wrong. You know, I'd say if one person in the class got it wrong, that'd probably be too much, because it's kind of an easy thing. Okay, so corpus callosum. The fornix, not shown so well. It's been cut up. Maybe if we break this open a little bit, it might look a little better for you. See, this thing is the fornix. So look at your brain models. It's not even better over here either. Seems like this is totally a separate, different brain, but it's also been cut. It's this piece here. It mimics it's usually a little arching, and it's under the corpus callosum, but that's it. I'll try and perhaps on Thursday show you a different brain. We have a dozen or two brains. I just picked a couple of decent ones, but it's not decent for a fornix, but that's okay. This is fornix right here. Just a little cut up. And then olfactory bulb and tract. Those also are rather mediocre on the whole brain. Here is an olfactory tract. It looks like the bulb has been broken off at the end. It would probably be here, but that's an olfactory tract. So that's the olfactory tract. It would be right over the nose of a human. Let me see this one. It's better. It still kind of looks a little like it's degraded, but that's the bulb is the end, even though it doesn't look too bulby. And then the skinnier part that goes in is the tract. So this is decent. It's not great, but it's decent. Olfactory bulb and tract. The bulb's at the end. The tract is the skinny part that goes in. Okay, if I'm not getting it to you, it's not conscious, just let me know, and I'll try and let you see it. Let's look over here. We might see. It's dangling off. It looks like it's been tied off. That black piece of thread is tying off the olfactory. This is probably the best one. The end kind of looks bulbish. And then maybe on the other side of the thread is the tract, where it gets a little more narrow. So that's the best one yet. Olfactory bulb and tract. The fissures, longitudinal, lateral, and transverse fissure. So the longitudinal fissure this is the dura mater, by the way. We'll get to that. So the longitudinal fissure separates the two hemispheres. pretty big, but it's best to see it on a whole brain because usually the cut is right down the longitudinal fissure when you make a cut of a brain, the sagittal cut. The transverse fissure separates the cerebellum from the cerebrum. Okay, so this is the transverse fissure. Brain is leaking. Transverse fissure. Lateral fissure, no super examples, but we can still kind of see where it is. It's right in here, lateral, to the side, lateral fissure there. I don't know about this one, it's kind of here. I don't know about this one either. There's all these cuts from a sloppy Bio 182 student. But anyway, here's that lateral fissure. Okay, separates the temporal from the frontal lobe. Lateral fissure. Optic nerve, chiasma, arborvitae, and midbrain. I'm not sure why I put these in these particular order. We already saw the midbrain, so that was the midbrain. I should have probably put it with the brainstem. I don't know what's the matter with me. So, optic nerve and optic chiasm. That's seen on the whole brain. This is a pretty good view of it. So here are the two optic nerves. Those two are the optic nerves. They would go out to an eyeball. They've obviously been cut. One's longer than the other. They didn't cut them right. And when they come together, when the two nerves come together, that's the optic chiasma. And there's like a little dimple there. That's the infundibulum right in the middle of the optic chiasm. So I've got the pin. Basically, it's right in the infundibulum, and the infundibulum is attached to the underside of the optic chiasma. So, and you'll get to infundibulum shortly, but there it is now. So everyone see the optic chiasma and the infundibulum?
Do you mind turning it? The optic chiasma is like the wishbone area?
Yeah, the wishbone area. The two branches are the optic nerves, and when they come together, there's some blood vessels in the way. When they come together, where that pin is, it's the optic chiasma. Alrighty, and we'll get to the infundibulum, which is something you need to know. The pin's in it right now. The arborvitae and the midbrain, so just the arborvitae left. It's the tree-looking thing, whitish, lighter, at least in color, in the middle of the cerebellum. I don't know if you can see. Once you get up here close, you can see the difference in color. From a distance, it just looks all kind of pinkish brown, but you'll see the arborvitae looks a little different. This one, I think it was more clear. Yeah, you can see the arborvitae a little more distinctly in this dried up, desiccated brain. And we can't see it there because it's not cut open. All right, so we're good with that row. Thalamus, hypothalamus, pituitary, and infundibulum. These are a little tricky. The thalamus is this roundish ball. It's more or less on top of the midbrain. It's like a spherical, lobular, roundish, maybe like a olive shape. It's a little oblong shape. That's the thalamus. If we look at it in this one, thalamus, it's the intermediate mass, but don't worry about it just yet. It's this roundish, maybe it looks like an eyeball a little bit, that kind of a shape. On top of the midbrain, which looks withered and dried up in this specimen. So you got medulla, pons, midbrain, the bulgy lobular thalamus. Okay, so if this is the thalamus here, directly below and in front, hypothalamus. Very good. So we're in this nondescript area. Nondescript. It's below and in front of the thalamus. And here's the optic stuff. See, there's an optic nerve that's tied off. So this area here between the optic stuff, that would be the chiasma and the nerve, this area in here, a little under the thalamus, but mainly in front of it and under it, is the hypothalamus. I can put a pin in it. That sometimes that helps students because it's, I'll put it right where I would consider the middle of the hypothalamus. That would be hypothalamus. That it's just kind of, I don't know, it doesn't have really a shape or anything. It's below the thalamus, as the name suggests. Okay. Pituitary we don't have, so we'll have to wait. Don't cross it off. I'll try and get a different brain that has it. It's been they're usually on the whole brains. But as I mentioned, the infundibulum was with the pin here. So that's the infundibulum, and the pituitary would be on top of it, but it's not here. So that's infundibulum. Okay, almost to the end. We have two more rows. Ventricles and cerebral aqueduct. So the ventricles 1 and 2 are called the lateral ventricles, and we see that this big old cavity right here. So that's a lateral ventricle. That's a lateral ventricle. And then the third ventricle would be right where the thalamus is. Do you see how it's kind of in a little? Like if you put the other half on here, there would be some space in here. Okay, that's the third ventricle. It's very narrow and long. It's kind of like if the thalamus has 2 lobes, it does have 2 lobes, and then that space between the 2 lobes, the space between my hands, is the third ventricle. And when you cut the brain in half, which we've done here, you cut right through the third ventricle. So you can't really see it, but it's right here. I mean, we can see kind of half of it. It doesn't really look like a ventricle per se. That looks more like a ventricle. You see the fourth ventricle. And the lateral ventricle, because they're a little intact, this is the third ventricle. So you'd have to kind of read the question. If it says name the structure, it's the intermediate mass. The thalamus. If it says name the ventricle, that would definitely be the third ventricle. And then I believe the meninge layers. The dura mater is this thick outer membranous covering, dura mater. And then the arachnoid mater is this the thinner membrane underneath. So that's the arachnoid mater that you see there. Arachnoid mater, and then the thicker, heavy-duty dura mater on the outside. And I believe that covers... Oh, cerebral aqueduct. So the cerebral aqueduct connects the third and the fourth ventricles. So here's the third. Here's the third, right where the thalamus was. Here's the fourth, right in front of the cerebellum, behind the pons. And then the aqueduct is this groove. Is that working for you? It's a drain. Here's the third ventricle. It's the drain like the bathtub. It drains the cerebral fluid into the fourth ventricle. It's a groove. It's rather subtle. I think it's bigger here. This is a better cerebral aqueduct. It's that groove right there. I got the probe in. You see that groove connecting the third. The fourth ventricle looks a little ravaged, but that groove in there, that groove is the cerebral aqueduct. Okay. And it, once again, kind of a withered-looking medulla, pons, and rather small midbrain. Thalamus, hypothalamus, almost non-existent. Corpus callosum here. Fornix, kind of chewed up. Fourth ventricle, arborvitae, cerebellum, occipital, parietal, frontal, temporal, dura mater, arachnoid mater, lateral fissure, transverse fissure, longitudinal fissure, olfactory bulb, olfactory tract, optic nerves, optic chiasma. Here's the brain stem, but we don't really name too many parts there. Here's the vermis. Is vermis on there? Why isn't vermis on there? Vermis is on there, it's just not X'd under the human brain, but okay, fine. Okay, any questions? Want to see something again?
The pia mater?
It's not on here. Arachnoid mater's on here that we can see.